equals to cos 62 degrees, which will give us 0.469. D, power is equals to VI cos theta, which is equals to 50 times 2.34 times 0.469, which will give us 54.87 watts. Example 7. Figure 4.41 shows a circuit diagram of the example. If the frequency of AC circuit illustrated above is 500 over pi hertz, what will be the reactance in the circuit? Solution. In the LC circuit, the voltage VL and the voltage VC are out of phase by 180 degrees. Reactance capital S is equal to square root of XL minus XC squared. XL is equal to 2 pi FL, which by substituting the values we have 2 pi times 500 over pi times 0.9. Therefore, XL is equal to 900 ohms. XC is equal to 1 over 2 pi FC, which is equal to 1 over 2 pi times 500 over pi times 2 times 10 raised to power minus 6, which gives us 1 over 2 times 10 raised to power minus 3, which is equal to 10 raised to power 3 over 2, which gives us 500 ohms. S is equal to square root of, in bracket, 900 minus 500 squared, which gives us square root of 400 squared. S is equal to 400 ohms. Example 8. A source of EMF 240 volts and frequency 50 Hz is connected to a resistor, an inductor, and capacitor in series. When the current in the capacitor is 10 amp, the potential difference across the resistor is 140 volts and across the inductor is 50 volts. Draw the vector diagram of the potential difference across the inductor, the capacitor, and the resistor. Calculate I, potential difference across the capacitor, II, capacitance of the capacitor, inductance of the inductor. Solution. Figure 442 shows a diagram for the resultant of the current for the circuit. Then we are asked to calculate the potential difference. I is equals to V squared equals to VR squared plus, in bracket, VL plus VC all squared. Then substituting the values, we have that 240 squared is equals to 140 squared plus in bracket 50 minus VC squared. In bracket 240 minus 140 times, in bracket, 240 plus 140, which is equals to, in bracket, 50 minus VC all squared. Square root of, in bracket, 3800 is equals to 50 minus VC. Then VC, then plus or minus 194.494 is equals to 50 minus VC. VC is equals to 245 V, or minus 144.94 V. Therefore, VC is equals to 245 V. II. In II, we are told to calculate the capacitance of the capacitor. To calculate the capacitance of the capacitor, then VC is equals to I XC. Therefore, XC is equals to VC over I, which equals to 1 over 2 pi FC. Making C the subject of the formula, we now have 1 over 2 pi FVC. Then substituting the value, you now have that C is equals to 10 all over 2 pi times 50 times 245, which is equals to 1 over 245 times 2 pi, which will give us 1 over 2450 pi. C is now equals to 130 mu F. III, VL is equals to IXL. VL over 1 is equals to 2 pi FL. L is equals to VL over 2 pi FL, which is equals to 50 over 2 pi times 50 times 10, which is equals to 1 over 20 pi. L is equals to 0.0159 H or 15.9 mini H. Quanta. Chapter 5, we are dealing with quanta, particle, nature of matter, elastic properties of solid, nucleus, and energy quantization. Quanta. 5.1 Particle, nature of matter. Simple atomic structure. Particle in atoms. Atoms are made up of their fundamental particles, electrons, protons, and neutrons. The protons and neutrons are found in the centrally located nucleus of an atom, while the electron revolves around the nucleus along imaginary paths known as shell or orbits. N is the neutron, positive is the proton, negative is the electron. Figure 5.1 shows the atomic structure of an element. Characteristics of the subparticles of atom. 1. The protons has a positive charge and of 1. The electron has a negative charge and negligible mass. The summary of characteristics of subparticle is given in the table below. Subparticle: proton, charge positive, mass carbon 12 as standard 1, electron charge is 0, the mass is negligible or 1 over 1850. The subparticle is neutron, charge is 0, the mass carbon 12 as standard is 1. Atomic number. Atomic number Z is the number of protons in neutron of atom consigned. It is equal to the number of electrons, the nucleus of the normal atom. Mass number. The mass number A of an atom is the total number at the top of the chemical symbol and the atomic number at the bottom. Example, 3517 chlorine means that the chlorine has mass number of 35 and atomic number of 17. Thus, the chlorine nucleus have 17 protons and 18 neutrons. Isotope. Isotopes are atoms with the same atomic number but different mass number. Example, isotope of chlorine are 35 chlorine and 37 chlorine. Example 1. A. An atom of Z has mass number of 11 and atomic number of 5. How many neutrons are there in an atom of Z? B. There are 2 isotopes of chlorine with mass number 35 and 37 respectively. If the isotopes exist in the ratio 3:1, the lighter isotope being the more abundant, what is the relative atomic mass of chlorine? Solution. The mass number is equal to the number of protons, that is, atomic number, and neutron plus proton is equal to mass number. The number of neutrons in an atom Z, neutrons plus 5 is equal to 11. Neutron is in Z is now equal to 11 minus 5, which gives us 6. B. If the isotope of fluorine exists in the ratio 3:1, The lighter isotopes being the